Okay, today we're going to move on to Unit 7.4, Similarity in Right Triangles. So we've gone from similarity in polygons to triangles, and now specifically we're doing right triangles. So our objective today is that you're going to be able to identify similar triangles within right triangles. You're going to be doing that by forming three pairs of similar right triangles by using an altitude. So that is a vocab word that we've had before, and we'll remind you what that means, okay? All right, so the theorem. The theorem says, if you draw an altitude going from a corner, making a right angle with the opposite side, the corner I'm going to use is the right angle, and I'm going to draw it to the hypotenuse. So if I drop an altitude from the right angle to the hypotenuse, it's going to divide it into three triangles. All right, so I've got baby triangle right here, ACD. I've got medium triangle right here, DCB. And then I've got my original triangle, ABC. So those are the three triangles that we create by just dropping that altitude. The cool thing is that all three of those triangles are similar. Okay, so ACD, similar to DCB, similar to ABC. All right, so three similar triangles. All right. Okay, so first let's just make sure we can name these. All right, so looking at this one, it looks like I'm going to start with the baby. Okay, the baby triangle, and I always like to start with the right angle, so I know I'm labeling them in the right order. So I'm going to say, I'm going to start with W, go to the short leg, go to the long leg, okay? So WXY is going to be congruent. Let me change color. Let's do this medium triangle here. The right angle is still W, short leg would be Y, long Z. All right, and that would be congruent to our, not congruent, similar, to our big one. Here my right angle is down there, so that would be starting with Y, short is X, long side is Z. Three similar triangles. Okay, so what do we do with this information? We can find side lengths. That's the point of this. So our corollary to the theorem, it has a lot of math terms in it, but we'll break it down. It says the length of the altitude to the hypotenuse of a right triangle is the geometric mean. Okay? So geometric mean has to do with setting up a proportion and solving it. Okay? Just like we've been doing. Set two ratios equal to each other and then cross multiply. That's what we're going to be doing, okay? So let's take a few examples. I think you will see how this works out. All right, let me get this a little bit thinner. All right, so example 2, it says find X. So X is right here. Now, if we're looking at this, we have to remember this is one diagram, but it actually has three triangles in it. So the way I would look at this, if I set up a proportion to, let's see, in this median triangle, that side would be my hypotenuse. This side would be my long leg. So interesting. If I set up a proportion that looks at the long leg, okay, over the hypotenuse. So this is my long leg. That means it's longer than this one right here. My long leg is 36. My hypotenuse, the side that's always across from your right angle, is X. So I've got 36 over X, and if I set that equal to the same exact pairings, the long leg over the hypotenuse, but I need to choose a different triangle. And it looks like they gave me this length is 72. So the length of the hypotenuse in the big triangle. So the length of the hypotenuse in the big triangle, oops, get that going. Come on. 72 would be my hypotenuse there. And all of a sudden, x, that becomes my long leg for the big triangle. So this side, x, actually changes from being the hypotenuse to being the long leg, depending on which triangle you're looking at. So at this point, I've got long leg to hypotenuse is equal to long leg over hypotenuse. We know if we set two things equal, we can cross multiply. All right, so I'm going to cross, and I'm going to cross here. What that gives me is an x squared equal to 2,592. All right, so I'm close to solving for x. I've got x squared. How do I go from an x squared to simply an x? Well, I have to undo the squaring. You undo the squaring by taking the square root. So if I take the square root of something that's squared, it's simply x. That means I got to do it on the other side as well. Okay? So if I take the square root of 2592, that's not a perfect square. I do end up with a fraction or a decimal. And we're just going to round that to the nearest 10. Okay, so that probably is not clear yet. We're going to have to do this a couple times for it to gel. So let's look at another example here. Okay. All right, so here we've got, I look at this small triangle. I've got what I would say is a long leg and a short leg, because this down here would have been the hypotenuse. So if let's just set up a proportion where I'm going to look at the short leg over the long leg. And I'm going to set that equal to the short leg of the big triangle over the long leg of the big triangle. So my short leg would be 49, my long leg, and right? That makes sense. My short leg is x, my long leg is 49. Okay? And then if I'm looking at my big triangle, I've got in here, they give me this, but that looks like the hypotenuse, right? I don't want the hypotenuse because I'm not using the hypotenuse at all. Interesting. Maybe I'm not using the big triangle. Actually, it looks like I could use that small triangle because I do have a long leg right here. That long leg is now, or x is now the long leg of that short triangle. So that means I need to find what that short leg right here is. Luckily, they've given me enough information to do that. So I need to do a little scratch work on the side. 58 minus 49. 58 minus 49 leaves me with 9. So 9 is just that little section right there. That is my short leg. So I've got short to long, I can cross multiply. That leaves me with x squared is equal to 441. I don't want x squared, I want x. Take the square root of both sides. That's going to leave me with x is equal to 21. All right, last one. Okay, now this looks a little scary because I've got square roots in here. I think on this one, if I look at this medium triangle, I've got a long leg and a hypotenuse. Long leg over hypotenuse. Okay, so I know that's going to be 25 over 5 times the square root of 37. All right, so where's my other long leg and my other hypotenuse? And definitely here is my hypotenuse. They labeled it x. All right. That tells me it goes on bottom. My long leg is 5 square root of 37. All right, so that doubles as the long leg in the big triangle. It's a hypotenuse in the medium triangle. I've got to cross multiply. 25 times x is 25x. And 5 square root of 37 times 5 square root of 37 ends up being 925. Divide each side by 25. And I do come out really nicely. X is going to be 37.